I'm gonna record. Yes. Okay. I think I can start till 29. Okay, I think I can start now, guys. Okay. So good afternoon, everybody. I wish you are healthy and safe in this crazy time. So let me tell you first what we did last time. Last time I was explaining how can we use, let me change the pink color. Last time I was explaining how can we use the switches. As you see here, guys, we have 8 switches. So every little switch here, this is one switch. So we have 8 switches, okay? I was explaining these switches. Let me summarize quickly before I proceed. I just want to make a very quick review on what we did last time. What I told you last time on this board, just give me 1 second. Like this one. Okay. On this board we have 8 switches. Okay. Okay. These switches are connected to port H. Is that okay? That's what I told you. This is how the port was designed. This is how they designed the port to connect these switches to port H. And I told you the way they are connected is this way. For example, I'm going to give you one switch as an example, but actually the other switches are exactly the same thing, okay? So let me give you one switch as an example, okay? For example, if this one is BH0, okay? So this one is connected here, resistance, and then 5 volt, and then here a switch, and a very small resistance. I'm gonna consider it like a short circuit, very small resistance, something like that. Okay, guys. So from electronics point of view, if you look at the what's happening here in electronics, we have 2 cases. Okay. Now, number one, if the switch is open, this case, if the switch is open, almost there is no current here. So zero current. Almost there is no current. That means on this pin, the voltage is very close to 5 volt. Okay, which means when you read this pin, you are gonna get logic 1. Okay, that's what I said last time. This is how we made the hardware. Okay, guys, that means if you read one bit and you find this bit is 1, what it means? It means the switch is open. Okay, now let's consider the other case. The other case was here you are gonna connect the switch this way. Okay, so what's gonna happen, the current has to go this way, and this is 5 volt, and this is PH0, and the volt here is gonna be 0 volt. Okay, because there is a 0 volt when you read this bit, you are gonna find logic 0. Is that okay? That's what I said, guys. Okay, so at the end, what we are doing is we have a byte for port H. It's a byte. Okay, every bit in this byte can tell you if the switch is open. So if it is 1, it means the switch is open. If it is 0, it means the switch is closed. Okay, guys. I explained hardware. I explained circuit. Also, I explained in software how it looks like. In software, if the bit is 1, that means the switch is open. If it is 0, the switch is closed. Okay, I just want to tell you something important, guys. It doesn't need to be all the time this way. It doesn't need to be logic 1 means open, logic 0 means closed. It doesn't need to be this way all the time. It depends on how you design the external circuit. Okay, in our case, if the switch is open, we actually put 5 volt. Okay, that is why we read 1. Okay, so what I want to say is, if you choose the hardware, the circuit, external circuit, it may be something else. It may be 0 means open, okay, 1 means closed. But here I'm talking about our the design of this port. Okay, so that's what I explained last time, guys. We have 8 of these switches. Okay. Also, I explained all what we have to do is all what you have to do. You have to read this bit to know if it is 0 or 1. If it is 1 means the switch is open. Now the switch is closed, and if it is open I have to do something. If it is closed I have to do something else. So that's what I explained last time. I explained, you remember when I used this switch as for on off for the system. Okay, if in one position I'm gonna consider one, so I have 2 positions. Don't ask me which one is on. It's up to you. What I want to say, we have 2 positions. I'm gonna consider this position, system should be on. I'm gonna consider this position, system is off. It's up to you. The switch can have 2 positions. Okay, maybe you can do the other way. It doesn't matter. It's not a big deal. You have 2 positions. One position I'm gonna consider it. The system should be on. But what I mean by system here is the buzzer. Do you remember last time when we ran the buzzer? So in one position I'm gonna run the buzzer. In the other position I'm gonna turn the buzzer off. Okay, and that's what I explained last time. And all what you have to do, guys, you have to check one bit. And I'm not gonna explain it. I already explained it several times. If you have a byte in chapter 2, even I explained it last time. If you have a byte, how can you check if this bit is 1 or 0? Okay, and based on the result of this check, you have to take action. Okay, either, for example, in case of 1, buzzer should be on. Just I'm giving you example. In case of 0, buzzer should be off. Okay, guys, that's what I did last time, and I give you one program. Okay, any question here before I move forward and I explain more stuff? Any question, guys? Okay, now I told you we have 80 switches. Also, if you go to the board, I want to see you something here. Also, here we have, okay, I cannot erase it. Okay, that's okay. So also, if you look here, guys, we have 4 push buttons as well. That's what I'm gonna explain today. Okay, I started last time. I'm gonna continue working on this one. We have 4 push buttons. Okay, tell me what is the difference between switch and push button. You should know, but I'm gonna explain it very quickly. Okay, so switch. In a switch, guys, it has 2 positions. Okay, so the switch, it can be open this way or it can be closed this way. So this is open, closed. Okay. The main difference between a switch and push button is if you open a switch, it's gonna continue open all the time until you change it to close. If you close the switch, it's gonna continue closed forever until you change it. Okay, this is the main difference. Okay, so this is okay. What about push button? In order to understand this difference, push button is different. What happens in push button is the following. Look here, guys. It's something like it's like your door bell switch push or push button. Sorry, button. Okay. So what happens here, guys? It has a spring. There is a spring here. So when you press, so let me erase this one. So here, when you press, you connect. Actually, you make a short circuit when you press. So it's gonna become something like that. Once you release, actually it's gonna return it back open by itself. by itself. Okay, so I can say, let me say it this way. So the push button is always open, okay, unless just it is closed, only closed when you press. Once you release, it's gonna be, so all the time it is open. Okay. Any question here? You can see the main difference between switch and push button. So switch, if it is open, is gonna continue open forever until you change it. Okay. A switch is different. A push button is different. Push button, it is all the time it is open. Once you press, you connect. Once you release, it's gonna open again. Is that okay? Okay. Now, so how? Number one, you told me we have 4 push buttons. Okay. Number one, where they are connected on the in the board. Okay, they are connected on port H as well. Oh, so here is for BH0 until BH7. I told you we have 8 switches. Okay, guys. Also, from BH0 to BH3, we have 4 push buttons. Okay, that means we have four pins here that have a switch and push button. Okay, how it is? I'm gonna tell you how. Okay, it's gonna, so this is, for example, BH0. It's gonna be connected this way, guys. So we have resistor here. We have 5 volt. Here we have this is switch. Also here we have a push button this way. Okay, guys, this is how they made the board. Okay, that means, okay, so number one, and you should understand very well. Okay, so now we have a switch and we have push button. Okay, it is not supposed to use both of them at the same time. Okay, so if I select BH0, I'm gonna use the switch. That means I should not use the button, or the other way. If I use a button, I should not use the switch. Is that okay, guys? So I have to use only one of them. I shouldn't use both of them at the same time. At the same time, that's what I'm saying. Okay. So if I need one push button, okay, I'm gonna use this push button. That means this switch has to be open all the time. So I'm not gonna use this switch. Okay. Someone can ask me, why they made the board this way? My answer is, okay, they made it this way because it's for education purpose. Okay, guys. For example, you may do a project and maybe you need all the switch and you don't need any push button. Okay, maybe in another project you need only one push button and you are going to use the switches. So that's why they put both of them, switch and button. It's up to you based on what you are doing. When you make your own design, when you make your own microcontroller, you should not do it this way. Is that clear? When you make your own microcontroller, usually you should connect only a switch to a pin or a button to a pin. Okay, guys? So tell me how it works, how this button is gonna work. Same thing as I explained before. If you don't press, look here, guys, if you don't press, let me have a laser. Okay, look here, if you don't press the button, so here is going to be 5 volt because exactly same thing as explained before, because there is no current here. The current is 0, okay, because both of them are open, and here is going to be almost 5 volt. Okay, that means if you don't press the button, that means I should get logic 1. Makes sense, right? If you don't press the button. When you press the button, you actually make a short circuit here. And now this volt is going to become 0 volt. And the current has to go this way. Okay? Here 0 volt. If you press the button, that means BH0 is going to become logic 0. Okay, guys. So if I wanna draw like a signal, the signal should be something like that. It is 5 volt all the time. 5 volt all the time. This is, I'm writing BH0. Okay. When I say 5 volt, it means logic 1. 5 volt here, but inside the microcontroller, in the software, when you read it, it's gonna become logic 1. So it's the same thing. So this is BH0. when you press here, you press. You actually are when you press, you are going to bring it to 0. Okay, here you hold. So you press and hold. Okay, once you release the spring, here you release. Okay, the spring is going to bring it high again. Okay, guys, is that clear? So let me summarize what I'm saying. This is how the signal should look like on the PH0 if you use the push button. It's going to become high. Here you press and then you release. And then here you press and here you release. And so it should be look like something like that. Here again you press. Sorry, I have to turn my phone off. Okay, here you press, here you release. Okay, same thing here, press, here you release. Okay, I want to tell you something very, okay, let me go back. Very, very important. Okay, it's like can make mistakes. You may waste a lot of time to look for where is your mistake, and that's a very simple mistake. So look what I want to say here, guys. Okay, so what I'm saying here, guys, if you want to use the push button, if I want to use the push button here on PH0, you have to make sure the switch is open. I'm gonna say it again. If you want to use the push button, you have to make sure the switch is open, because if the switch is closed, guys, what's gonna happen is, let me just clean it a little bit and then I'm gonna explain it. Okay, so let me clean it this way. Okay, let me just, yeah. What I'm saying, guys, if you connect the switch, that means there is 0 volt here. This 0 volt is coming from the switch. Is that okay? And now, if you press, or don't press, it's not going to make a difference, because the 0 volt is coming from here, from the switch. So you're not going to get a signal like this one. So your program is not going to work. You understand what I'm saying, guys? This is a common mistake. Some students come to me, look, my program is perfect. I'm sure it is okay. I'm sure it's working. But look, when I press, it doesn't do anything. You okay, guys? So this is because the switch is connected. So what I'm saying, okay, so it's 0 volt all the time. So press or you don't press is not gonna make any difference. Okay. So what I'm saying, if you decide to use this one, you have to make sure the switch is open. Okay, so that you can get a signal like this one. Okay. Any questions before I move forward? Okay, so this is for the push button, guys. This is how the signal is going to look like using push button. Okay, how the signal is going to look like if you use a switch. If I use a switch, it's going to become all the time it is high. Here I'm going to change the position of the switch. It's going to continue low. Is that okay? And then when I change the position, it's going to become high. So it's not going to, for sure you should, because you should understand the difference. Okay, here in the push button, okay, there is a spring. So once you release, it's gonna go high again. Here it's a completely different story. Here you change the position of the switch. Same thing here. Okay, so once I bring it low, it's gonna continue low forever, and so on. Is that okay? Okay, so this is how the signal looks like if you use the push button. This is how it looks like if you use the switch. Now, and this is the most important thing, listen to me. Okay, now, if I want to use the switch, and that's what we did last time, if I want to use the switch as on-off, I assume like I have a buzzer, and I'm going to use a switch to turn the buzzer on or off, or I have a system, and I'm going to use the switch to know if the system should be on or off. Okay, guys, this is that's what we did last time. Now you can see, guys, the switch has 2 positions. Okay, so if I read PH0, I can know if the switch is in position 1 or if it is in position 2. I'm gonna consider one position is on, one position is off, and that's it. So if I need to know if the system should be on or off, all what I have to do, I have to ask pH0. Is that okay? pH0 is if it gives me 5 volt, that means the switch is in one position. And it's up to you. I'm going to consider this position is on. I'm going to consider this position is off. Or maybe it's the other way. It doesn't matter. Okay? So now I have two positions. Okay? One of them I'm going to consider it is on. So what I want to say is, if I want to use a switch as on-off for a system or something like that, okay? All what I have to do is, I have to read pH0, for example. If pH0 is 5 volt, that means the system is on. If it is 0 volt, that means the system is off. Is that okay? And so on. Very easy way. Is that okay? Now, if I want to do the same thing but using push button, so it's completely different story. It's a completely different story. Okay? So if I want to use the push button in order to make the system on and off, it's a different story. Why it is different story? Because if the system is off, initially the system is off, and when you press, it has to be on. When you press again, I have to make it off. When you press again, I have to make it on. That's what should be. This is how it should work. Every time I press, if the system is on, I'm going to make it off. If it is off, I'm going to make it on. Is that okay? The problem is that you should look at this slide and see how they are different. The problem is that if the system is off and I go and read pH0, for example, pH0 is going to tell me I am 5 volt, okay? If the system is off, also it's going to give me 5 volt, okay? This is completely different from what we did here. What we did in the switch is, because the one value is going to tell me if the switch in position 1 or in position 2, right? Here the switch always is going to give me 5 volt, always, okay? Only at the moment you press and you hold, this is going to be 0, but all the time it is off. You understand, guys, the difference between both of them? So let me summarize. What is the problem? And then I'm going to tell you how we can solve it, okay? What I'm explaining right now, guys, is that you have a system, okay? This system, for example, like a buzzer. That's what I explained last time, okay? And I want to use one switch or one push button to turn it on and off. Is that okay? So if for the switch, it's easy case. Why it is easy case? Because if I want to know if the system is on and off, all what I have to do, I have to read pH0. pH0 should give me 0 volt or 5 volt, logic 1 or logic 0, okay? I'm going to consider one of them on, the other one is off, because it's only 2 positions, okay? So all what I have to do, I have to read pH0. If pH0, logic 1 or 5 volt, so I'm going to turn the system on. If it gives me 0, I'm going to turn the system off, and so on. So it's easy case, okay? I cannot do the same thing in push button. Why you cannot do the same thing? Because in push button, it's always 5 volt. All the time it's 5 volt, unless only in the very small time, very small period. You press just very short time. You press and you release. Is that you are? I think this figure is what I'm doing here is it can convince you. Okay. So what I said here, guys, is look here. I assume. Oops. Let me. I want to make laser. So here, guys, I'm assuming the system is off. Is that okay? And now, when I press, the system should be on. So that means from here to here, the system should be on, right? Okay. But if I come and ask pH0, it's going to tell me I am 5 volt. Is that okay? When you press now, so the system should be off. That means here, the system should be off. Because here this pulse or this, when you press the button, you change the status of the system. So now it's off. Okay. So what I'm saying, pH0, if you read pH0 here, in both cases is gonna give you 5 volt, and here should be on, here should be off. That means case is completely different from what we are doing here. It's not enough to read pH0 to know if the system is on and off. Okay, what should we do? This is a problem. Before I talk about the solution, anybody here has a question about this problem? You understand? You should. Let me summarize what I explained before I move forward. Okay, what I explained Okay, what I'm explaining, we have push buttons, we have switches. Okay, what I explained, the switch should have two position. Push button, when I press, I'm gonna pull it low for some time, and then it's gonna become high again. What I'm explaining is, if I want to use a switch as on-off switch to turn something on and off, I need to know if the system is on, I'm going to turn the system on. If it is off, I'm going to turn it off. And in case of switch, it's very easy. You just to go and ask PH0. PH0 is going to tell you, right? This is easy case. In case of push button, no. Because if you go to ask PH0, most of the time PH0 is going to give you 5 volts. If the system is on, it's going to give you 5 volts. If the system is off, it's going to give you 5 volts. So it should not be this way. We have to do something. Okay, this is the problem I'm going to explain now. Any question before I explain? Okay, in case of push button, how I can use push button as on off switch, as for making the system on off, not a switch. I'm going to use push button for on off. Okay, any questions? Okay. So the idea here, guys, is the following. I have to use a variable. I have to use a variable. This variable should always record the status of the system. On or off. Is that okay, guys? So assume I'm gonna call this variable, for example, status. Any name, just any name. This variable should have two values. For example, it can be 0, 0 or FF. Okay, 0, only this variable should have one of two values. It cannot have any other values, one of two values. I'm gonna consider 0, 0 means the system is off. I'm gonna consider FF means the system is on. Okay, guys? So number one, I have to use a variable. Okay, this variable should echo or should record the status of the system. Is that okay? So if I wanna know if the system is on or off, I have to go to and ask this variable. Okay, I'm gonna call it a status. Can be any name. Okay. So what's gonna happen is the following, guys. Look how it works. This is status, which is a variable. Okay. So here I'm assuming in the very beginning the system is off. That means the status should be 0, 0. This is the status. Okay. And now when you press the button, okay, that means I'm gonna make a status FF, and it's gonna continue FF, because now the system should be on, right? When you press the button again here, so means the system has to be off. That means I'm gonna change the status to 0, 0 again, and then same thing again. When you press again, I'm gonna make the system on, so I have to change the status to FF, and so on. Is that okay, guys? So let me explain in just a few, in just a couple of sentences how it works. Okay. Number one, guys, I have to use a variable to capture, to record the status of the system. This is number one. Number two, every time you press a button, I have to change it from on to off or off to on. So I have to change the status. If it is on, I'm gonna make it off. If it is off, I'm gonna make it on. This is number two. Every time I press the button, if you don't press the button, I'm not going to do anything, because the status is going to be the same. So here, you don't press the button here. So I'm not going to do anything. If the status is on, it should continue on. If it is off, I'm going to continue. Only I'm going to change the status, I'm going to change the variable only when you press the button. Is that okay? So when you press the button, I have to change the number I record in status. Okay? If it is 0, 0, I'm going to make it FF. If it is FF, I'm going to make it 0, 0. Okay? Then at any time means here or here or here. At any time, if you want to know if you should run the system or not, all what you have to do, just to go and ask status. Okay? If status tells you I am 0, 0, that means I should turn the system off. If it tells you I'm FF, so you should turn it on. Okay? Any question, guys? I'm going to show now a program. But if you have any question, you can unmute your mic and ask me, okay? You understand? You should understand what is the difference between what I'm expecting from you to understand here. Number one, you should understand how a switch is different from push button. This is number one, okay? Number two, last time I explained how can you use push button to turn a system on and off, okay? And all what I need to know, I need to check if the system is on, I'm going to do something. If it is off, I'm going to do something else. What I'm explaining today is how can you use the push button to do the same thing. Okay, so I'm going to use push button to make the system on and off. Okay, so that's what I'm explaining right now. Okay, it's a little bit complicated in case of push button, because you have to use a variable every time you press a button. So I'm gonna this variable should have one of two values, one for yes, for off, and one for on, right? And every time you press the button, you actually you change the status of the system, or you change the value from 0 to FF, or from FF to 0. At any time, if you need to check if the system is on or off, you just ask status. Don't ask PH0. This is the major difference between a switch. So in case of a switch, if I want to know if the system should be on and off, so ask PH0. PH0 is going to tell you, okay? Because 5 volt means on, 0 volt means off, okay? But in case of push button, don't ask PH0, is not going to tell you, because PH0 all the time it's 5 volt. It's not going to tell you, right? If the system is on, it's 5 volt. If it's off, it's going to be 5 volt. So if you want to know if the system is on and off, just ask the variable. This is number one. Number two, every time you press the button, you have to change the value of this variable, okay? Any questions before I choose a program? Any question, guys? Okay, so let me choose a program, how I made something like that, how I'm gonna use it in the program. Yeah. So what I wanna do here, guys, similar to, let me, I wanna repeat the same program I explained last time. When I use, let me go the program I'm referring to. So I'm referring to this. I'm referring to this program, guys. So last time I explained. This is the police siren, if you remember. So this is the police siren. Oops. Let me. I just want to change the color. Okay. So this is the police siren program is here. You remember last time? And what I did in the beginning, every time I come here to the beginning, I'm gonna check if the system should be on or off. If the system is off, I'm gonna loop to here. So I'm gonna keep looping here. I'm gonna check again. I'm gonna wait until you turn it on. That means I'm not gonna come to here. That means I'm not gonna run the buzzer. Yeah, because the system should be off. I'm gonna wait here. I'm gonna loop to forever here. That's what I did, right? If the system is off, I'm gonna loop here. If it is on, I'm gonna come here. So if it is off, oops. What's going on? So if it is off, I'm gonna loop to here. If it is on, I'm gonna come here to run the buzzer. Okay, and this was, I want to do the same thing, but instead of using a switch in this case, and what I'm gonna explain now, how can use the push button. Here it is very easy case, as I told you, because all what I have to do, I have to just go and ask port H. That's it. But in case of push button, it's not enough to, you shouldn't, it's not going to help you to ask PTH or PH0. It's not going to help you. But what you have to do, you have to use a variable as I explained, and that's what I'm gonna repeat exactly same program, but here I'm gonna use push button. Okay, so I'm gonna show you now how it works. Okay, guys. Now, number one here. Okay. This part is just a configuration. Okay, so here you configure PT5 because this is where the buzzer is connected. Here but this is a mistake. This should be port H. Okay, so here you have to configure port H as input because the switches or push buttons are connected to port H. So I'm going to use port H as I have to configure them as input. Okay, and then look here, guys. This is the police siren here. Okay, but before I come here, before I come here to run the, so if the system is on, I have to come here to run the police siren. And then here I have to check. This is a check part. It's a little bit bigger than what we did before. So here you check, okay? If the system is off or on. If the system is off, I'm gonna loop back to here if it is off. So now if the, sorry, oops. So if the system is off, I'm gonna loop back to here and to check again. If it's off, I'm gonna keep looping here. I'm gonna explain to you how, okay? But if the system is on, so I'm gonna go back. If it is on, I'm gonna go back this way and then go back again to the beginning to check again, because you may change the state of the system at any time, okay? So how it works. So here in this part, guys, I'm gonna check if the system is on or off. If it is off, I'm gonna loop back to here to check again, okay? If it is on, I'm gonna go this way, okay? So how it works, I'm gonna explain now how it works, okay? Number one, as I told you guys, I'm gonna use a variable. This variable should tell me if the system should be on and off, okay? And I design, this is the variable I'm gonna use. Any name, when I explained it, I called it status. Here I'm calling it on off, any name, doesn't matter, okay? So if you want to call it status, it's okay. If you want to say it on off, it doesn't matter. So this variable should take one of two values. If it takes 0 0 or if 0 0 or if, okay guys? So if this variable is if, that means the system is on. If it is 0 0, the system should be off. And if it is off, if it is if, that means if it is if, that means when you push the button, I have to come here. When you push the button, I have to come here. Is that okay? This should happen when you push the button. Here when you push the button. Is that okay, guys? So every time you push the button, I'm gonna move from here to here or here to here. Okay. Someone can ask me why you selected the numbers 0 0 and FF. I selected this number. Okay. You can, for sure you can select any numbers. You can use 7 and 8. You can use 10 and just any two numbers. It doesn't matter. But the reason I use these two numbers because it's just very easy to move from one number to another. How? Complement. You got what I'm saying? So every time you push the button, I'm gonna complement this variable. You got what I'm saying? This is the only reason I use these two numbers because it's easy to every time you press, I'm gonna complement this one to move from FF to 0 0 or from 0 0 to FF. Now I'm gonna explain how it works here, guys. Okay. So let's see how it works. Number one, I'm gonna check PH0. Okay. Now, what if it is set? If PH0 is set, that means 5 volt. Okay. What it means? If it is 5 volts, that means I should not change the status. I'm gonna just check the status. If it is on, I'm gonna run the system. If it is off, I'm gonna run the system. Okay. So that's why I'm gonna go to somewhere called to start. Okay. So again, I'm gonna check PH0. If PH0 is high, that means you didn't press. That means I should not change on off. Okay. That means all what I have to do, I'm gonna check on off. That's what I'm doing here. So here, look here, guys. I'm gonna check on off. Okay. So here I'm gonna register register B equal on off, and then I'm gonna compare with 0. If it is equal 0, that means the system is off. I have to come to here. Okay. So what I'm doing here, guys, I have only to check on off. Okay. So if it is 0, I'm gonna come to here. If it is FF, I'm gonna go and run the buzzer. Is that okay? So this is the first case. Let me say it again, guys. The first case, I'm gonna check PH0. If PH0 is high, okay, that means I should not change the variable. All what you have to do, I have to come here and to check if the system should be on or off. That's what I did here. If the system is off, I'm gonna come back to here to check again. If the system is on, I'm gonna come to here to run the buzzer. Is that okay? Now, if I'm gonna look at this part here, guys. If PH0 equals 0, what it means? What it means? It means you press the button. Here, you press the button. That means because you press the button, that means I should change this value. Okay, so that's what I did here, guys. Here I'm gonna complement, as you see here, guys. So I'm gonna read on if, I'm gonna complement, I'm gonna return it back, and then here I'm gonna wait until you release. Okay, so what I did here, let me. Okay, so here, guys, because you press the button, I'm gonna complement. I'm gonna come to here, guys, only when it is 0. When it is 0, right? So when it is 0, number one, I have to complement this value. If the system is on, I'm gonna make it off. If it is off, I'm gonna make it on. This is number 1. Number 2, look at this one, guys. I'm gonna wait until you release. So I'm gonna wait here. I'm gonna wait until you release. Okay, how I'm gonna ask pitch 0. As long as it is 0, I'm gonna keep looping here. So I'm gonna keep looping here until you release. Okay, guys, any questions? Why you did this step here? Because if I don't do this step, what's gonna happen? When it is low, okay, I'm gonna complement, and then I'm gonna come back. And then I'm gonna come back. Maybe I'm gonna complement again, because in this period, okay, when it is 0, every time I find it 0, I'm gonna complement. Every time I find 0, I'm gonna complement. Okay, so the way I'm gonna do it, or what I wanna do, guys, if it is only 1 pulse, I'm gonna complement only 1 time. Every time you press, I'm gonna complement only 1 time. Okay, the way I'm gonna do it, once it is 0, I'm gonna complement, and then I'm gonna wait until you release. That's what I did here. So this part here, guys, is you complement. Here I'm gonna wait until you release, so that every time you press 1 time, I'm gonna complement 1 time. Okay. Any question, guys? Okay. So I'm done with this program. I'm gonna also explain the same thing using C language. It's gonna be the same structure or the same idea, but I'm gonna use the C language instructions. Okay, but quickly, I wanna just summarize what I said here quickly, guys. Okay, number 1, I used the variable on-off. This on-off can have one of two values. Okay, one value is gonna tell me the system is on. One value is gonna tell me the system is off. Every time you press, I have to move from here to here or move from here to here. Is that okay? So here I'm gonna come, and it's gonna check pH 0. There are 2 cases. pH 0 can be 0. If pH 0 is 0, that means you press the button. Because you press the button, I have to. That's what I'm saying here. I have to complement this value. If the system is on, I'm gonna make it off. If it is off, I'm gonna make it on. And then I'm gonna wait until you release. Is that okay? This is number 1. Okay. Number 2. If pH 0 is telling me it is 1. What it means if it is 1? That means I'm not gonna change the status of the system. Okay. All what I'm gonna do, I'm gonna just check. I'm gonna ask on off. Are you 0 or you are you FF or are you 0? Based on this value, I should make a decision. Either I go back to here. Sorry, I have go back to here because the system is off, or the decision I have to come to here to run the buzzer because the system should be on, right? So I have to make a decision, either go back or come here. Okay, that's exactly what it is. Any questions before I'm going to explain the same program? Let me see if I have the same. Yeah, I'm going to explain the same program in C language, but before I explain the same program, I'm going to tell you about a problem. Okay, I'm going to tell you about a bounce, what we call bouncing problem. Okay, and then I'm gonna let me first explain before I explain the same program and show you a video, very interesting video. Let me explain you a problem in mechanical. All mechanical switches suffer from this problem. Okay, so let me tell you what is the problem. Okay, the problem is that, look here, guys. So what I'm explaining here, this is called bouncing problem This is a problem in all mechanical switches. Okay, what is the problem? The problem, guys, what I told you right now is not like, it's what I explained right now. I explained like ideal case. What I explained, when you press the button, okay, the switch has to come low, it has to come to 0. See here, when you press, okay, and then here you hold, and then here you release. At this moment here you release. Okay, this is not the reality. This is the ideal case. Okay, and that is the problem. Okay, if this is not the reality, how the reality looks like? I'm going to tell you how the reality looks like. The reality is that when you press the button, okay, because the switch has mechanical parts, there is no way that the switch is going to move from on to off in 0 seconds, because there should be some bouncing, because you have a spring, because you have some mechanical, okay, because of this bouncing, okay, when you press, it's going to make some bouncing. Bouncing means connect, disconnect, connect, disconnect. So this is what happened in reality. Okay, so what's going to happen is going to make some bouncing here before it becomes 0. That's what we call bouncing. Okay, again, this bouncing means is not gonna, the switches or the metal parts are not gonna connect directly. Okay, but this should be, because of the mechanical parts, is gonna connect here, connect, disconnect, connect, disconnect. Okay, for a very small time, around 5 milliseconds. Okay, same thing here, guys. When you release, it's gonna make some bouncing before. This is exactly how it looks like. Okay, let me change the color to tell you. Okay, so what I'm saying, guys, that's what I explained. This is ideal case. Okay, this is ideal mechanical switch. In reality, the mechanical switch should look like something like that. There should be some bouncing here and bouncing here. This is because of the spring, because of the mechanical parts. Okay, these parts make some bouncing. It's not going to be for long time. I think it's between 10 milliseconds or 5 milliseconds, very short period of time. Okay, that's okay. But what is the problem? You are telling me this is a problem and we have to address it. Yes, it is a problem. Okay, I'm going to tell you what is the problem, or how this, if you don't solve this problem, what's going to happen? I'm going to tell you what's going to happen. Look here, guys. I told you, every time you press here, guys, if the system is on, I'm going to make it off. Okay, sorry, if the system is on, I'm going to make it here off. Okay, and now if it is off, every time you press, I'm going to make it on. Okay, that's what I said. So because this is one press and this is one press. Okay, that's what I explained. What's gonna happen, yeah, guys, is when you press only one time, it's gonna look like something like that. Okay, this is only one press. You press only one time. Is that okay? What's gonna happen, because this is just between 10 or 20 milliseconds. Yeah, it's a very short period for us, but for microcontroller, this is long time. What's gonna happen? Microcontroller is gonna think this is one pulse, and this is one pulse, and this is one pulse. So microcontroller is not gonna take all of this as one press. Okay, guys, you got it? You got what I'm saying? So microcontroller is not gonna, because microcontroller is gonna be very fast. So microcontroller is gonna come here, you find it is 0, and then so it's gonna consider this one pulse, this is one pulse, and this one pulse. And I have a very interesting video. I'm gonna show. So that means I'm gonna show in this video how this problem. How this is a problem, okay, and I'm gonna solve it. I'm gonna show how the program is gonna work well when I solve it. Okay, so the problem here, guys, I only press one time, but microprocessor is gonna think I pressed 3-4 times. Is that okay? For sure, your program is not gonna behave as expected, right? Because you press only one time, only one action has to be taken. But because of this bouncing, Okay, microprocessor is going to take multiple actions because microprocessor is going to think you pressed too many times in a short. For sure there is no human being or we cannot make three. We cannot press 3-4 times in 10 or 20 milliseconds, right? It doesn't make sense. Okay, so number one, before I talk about the solution, do you understand the problem, guys? Again, I'm gonna say the problem in one sentence, and if you have any question, just unmute your mic and ask me. Okay, in one sentence, what is the problem? The problem is that this is ideal case. Every time I press one time, the program should take one action because it's one press, right? And this is the reality. What happened in reality, I'm gonna press only one time, but because of the bouncing, and because the microprocessor is very fast, microprocessor is gonna come check here, check here, check here. Microprocessor is gonna think I press this 3-4 times, so it's gonna take 3-4 actions. Okay, so for sure that's not what I wanted. I want to do. Okay, so the program is gonna behave completely different, and you will see now. Very good video. It's gonna convince you. So now, okay, so you told us the all mechanical switches suffer from this problem. That's true because of the mechanical parts. Okay, so tell me, okay, how we can? It's a big problem. It's a big problem. Why it's a big problem? Because when you press one time, the program should take one action, right? Because if I press one time and programs take 3-4 actions, so that means it's not going to work as I expected, right? So it's a big problem. It's going to make the push button useless. Okay. Okay, how can we solve this problem? To solve this problem, there are two solutions. Okay, one solution we call it software solution, and that's what I'm going to explain now. We have another solution we call it hardware solution. Okay, this is okay. Sorry. So let me now explain the software solution. Okay, in the software solution, guys, we are gonna do the following. Look here. Once you press here, guys, I'm gonna write a code. This code we call it debouncing code. Debouncing. You can tell from the English name. So it's like you are canceling the bouncing, or you are treating, or you are alleviating, or okay. So I want to cancel this bouncing. Okay. So every time you press, okay, I'm gonna write this code. Number one, I'm gonna wait 20 milliseconds. So when you press, I'm gonna wait until I just want to bypass this period. Okay. And then I'm gonna wait. So here, I'm gonna keep looping here as long as it is 0. So I'm gonna wait until you release. Okay, so this part here, once you release, that means I'm here. I'm here once you release, okay? Because you are here, so I'm gonna also have another 20 milliseconds. Okay, by this way, guys, because of these three parts, okay? If you put these 3 parts in your code, every time you press one time, I'm gonna take action only one time. Okay, so let me quickly explain it again, but let me erase this one. So here, guys, to solve this problem, the problem is that when you press one time, I want the program to take it as one press. I want the program to take only one action. Is that okay? How I can do that? Number one, when you press, so once it comes to 0, number one, here at this moment here, guys, I'm gonna write this code. So I'm gonna wait 20 milliseconds. This is number one. Okay. Once I come to here, that I'm gonna wait. I'm gonna keep looping here until you release. So I'm gonna keep looping. Okay, as long as it is 0, I'm gonna keep looping. Once it is 1, I'm gonna come to here. Okay. So here, once you release, I'm gonna wait another 20 milliseconds. Okay, and then after that, I'm gonna execute the rest of the program. Okay, by this way, by using this code, guys, if every time you press one time, I'm gonna take action only one time. Okay, any question here? So this code, guys, is called debouncing. Okay, this is how can we solve the problem. Any questions? Any question, guys? Okay. Okay, so let me go back here. Okay, I have another solution, but I'm not gonna focus too much on them. The other solution, we call it hardware solution. I'm gonna give you only one example. For sure, there are different solutions, but I'm gonna give you only one example. The one example, I'm gonna use a capacitor. As you see here, guys, this is the push button. Okay, so I'm gonna connect a capacitor here. Okay, what is the idea? Why you connect a capacitor this way? I'm gonna tell you what is the idea. Okay, without a capacitor, okay, guys. So what's gonna happen is the signal is gonna become this way without a capacitor, as I explained. Okay, with a capacitor, it's gonna look something like that. How the capacitor is gonna do this? I'm gonna tell you how. Okay, what's gonna happen is that what's gonna happen, because this switch is gonna connect to disconnect, okay? So when this switch is open for a very short period, okay. When this switch is open, okay, what's gonna happen? So what's gonna happen? This capacitor is gonna charge. When you close it, I told you it's gonna be open, closed. This is what makes the bouncing here. Switch is open, closed, open, closed, open, closed. Okay. So when it is closed, this capacitor is gonna discharge. Is that okay? So here, when here it is closed, so here is gonna discharge. Here, when it goes high again, here you charge. Okay, but because this time, the time for the bouncing is a short time, you open for a short period and then you close for a short period. What's gonna happen here? You charge. Is that okay, guys? But you are not gonna keep it charging until it becomes high because it's a short period. What's gonna happen is you are gonna charge for a little time and then the switch is gonna be closed, so you discharge. And then after some time, when it comes another ripple this way, so you are gonna charge. But the time is not, the bouncing time is not large enough to charge all the way to here. So what's gonna happen is, as you see here, guys, this is the voltage, it's 5 volt, okay? And then here it's 0 volt. And then here is gonna go a little bit up, like 1 volt or whatever, okay? But still, you know, for high, we have a range, for example, from 4.2 until 5 volt. For low, we have also a range. For example, I'm just giving you any number. I just want to tell you there is a range from 0 volt, for example, until 0.8, for example, okay? So what's gonna happen here, because this is a time here, this is a short time here, it's not gonna charge, still, yes, it is, you are gonna change from 0 volt, but you are not gonna go to high, okay? So it's gonna be like 1 volt or so that's what I want to say, okay? So the signal is gonna be some ripple here, but all this increase is gonna be interpreted as logic zero. Okay, guys. Anyway, so this is a hardware solution if you want to use hardware solution. But anyway, in this course, just very easy to use the software. Now, I'm going to show a program, very interesting program using C language. I'm going to show you a video, very interesting video. In this video, I'm going to explain to you. I'm going to show you just to understand how this debouncing is important. I'm going to show you. I'm going to cancel. I'm going to remove this part, the debouncing. You will see. When I press one time, the program is going to take multiple actions. Okay, you will see now. It's going to take one press. Is going to consider it like multiple presses. Okay, you will see when I put this code here, every time I press one time, it's going to take it only one time. You will see, you will notice it by yourself. But anyway, let me first explain the program before I show the video. Okay, so what I want to do here, guys, I'm gonna call it shifting LED. Okay, so the way it has to work, one LED should be on. For example, this LED is on. Every time I press a button, next one it should be on and this one is off. You got what I'm saying? It's like you are shifting LED. Every time you press one button, so the LED that is on, you move it. Okay? So always at any moment, only one LED is on. But when you press the button, I'm gonna shift like you are shifting. Okay? So if this one is on, you press the button, so this one is on, right? When you press the button, this one is on. once I come here to the beginning, once I press a button, so this one should be on. Okay, I'm gonna show you how the program works. Okay, so every time I press one time, okay, I have to shift LED once, only one, right? But because of the debouncing, because of the bouncing problems, that's what you are going to see in the video. Okay, because of the bouncing problem, when I press one time, the LED is going to be shifted 3, 4, 5 times, because one press is going to be taken like 4, 5 times. You got what I'm saying? But if I put the code for bouncing, for debouncing, okay, when you press one time, the LED is going to be shifted once. Okay, so let me show you now the program. Okay, this program is in in C. Okay, so now look here, guys. This part is just initialization. I'm not gonna talk about it or quickly. For sure, I'm gonna use port H. I'm gonna use push button in port H. Okay, so you have to configure port H as input for sure. Also, I have port B. Okay, because I'm using LEDs. Same thing for here. Because you are using LEDs, you have you have to disable 7 segment, so nothing is new here. Okay, so this part is just configuration. My program, the program should start from here. Okay, because this part here just a configuration. Okay, so let me. So here, just configuration one time. The program should be this part, or the main part. For sure, there's a whole program, but this is the main part is here. Okay, let's see how this program works, guys. Look here, guys. Number one, I'm gonna look at this. This is a push button, right? If the push button is 1, what should I do? Nothing. Just I'm gonna keep looping here, right? So if you don't press, I'm not gonna do anything. Make sense? Right? Because what I want to do when I press the push button, I want to shift the LED. Is that okay? But if you don't press, okay, that means I'm gonna wait here. I'm not gonna do anything. Okay, I'm gonna explain this program first in assembly, and then I'm gonna explain it in C. Okay, so here now. So here, I'm gonna loop to here. If you no press, if you don't press the button. If you press the button, I'm gonna come to here. If you press the button, because no press means PH whatever. I don't know which one he is using. PH whatever. So this is PH 0, 1, 2, 3. PH 0, 3 equal 1, right? Or equal 5 volt, right? Or 1. Okay. If you press, that means PH 0 should equal 0 volt, okay? Or logic 0. Okay. So here I'm gonna come to here. If you, no press is here, and if you press, I'm gonna come to here. Okay. So when you press, what should I do? This is the debouncing code. This is the code I have just explained now. This is the debouncing code. Is that okay? That's what I'm gonna do now in the video. In the video, I'm gonna delete this code. I'm gonna show you, okay, what's gonna happen when you press, and then I'm gonna put it to understand why pressing is important. Okay. Now, so every time you press, guys, okay, I'm gonna shift port B. Shift. Okay. When I shift port B, that means if this one is 1, when you shift, so next one is 1, right? So next one is gonna become 1. So you shift the 1 because only one LED has to be on. Okay. And then after I shift, now if I shift all the way to the end, so that means port B should equal 0, 0, 0, 0, 0, right? So what should I do? I have to bring it back to here, right? So once I turn if this LED is on and you press, you shift. So now this one it's like rotate. Okay, I wanna turn this one on. Okay. So how I can do this part? Look here, guys. What I'm gonna do now? I'm gonna shift, and now if the result of the shift is 0, okay. So if port B equals 0. 0 means I shifted this one, I shifted all the way to the end. Okay. So now if port B equals 0, 0 flag should equal 1. That means here what I'm saying, if not equal, come to here. So if the 0 flag equals 0, so just to come to here, and then from here I'm gonna go to the beginning again. Okay. Now if the 0 flag, I'm gonna come to here if the 0 flag equal 1. Okay, that means if I shift all the way to the end, now port B equals 0. What should I do? See what I did here, guys? Sorry, we are shifting left. I'm sorry. It's same thing like what I explained. I was explaining it's the same thing. What I was explaining, we are shifting right. I'm sorry. What we are doing, it's other way. You are shifting left. It's not a big deal. Okay, so you can change it if you want. So the way we are gonna do it, guys, I'm sorry, we are gonna shift it this way because we are shifting left. So once if the 1 is here and once you shift it, that means I have to bring it back to here, right? Okay, so that's what I'm doing here. If you see here, guys, if you shift left, and now if port, there are 2 cases. Port B does not equal 0. It's gonna come to here if port B equals 0. If port B equals 0, so I have to return it back to here, right? So I'm gonna put it back to here. Okay. Anyway, and then I'm gonna go to the beginning again. Any questions? You are okay? Okay. So why? This is a very good program because this program can explain the purpose of this program to understand why debouncing is very important. Okay. So you will see now why you will see now, guys. Look here, guys. If I don't use the debouncing code, what's gonna happen is the following. Look here, guys. Once I come here, once it is 0, let me go back to here. Oops. Okay, so once I come to here, guys, once it is 0, I'm gonna come to here for sure. I'm saying if I don't put this part, and then you shift 1 time, and then you come back to here, and then once you come to here, you make another shift. Once you come to here, you make another shift, and so on. So although I press only 1 time, but I'm gonna make 3, 4 shifts, and that's what you are gonna see in the program right now. You get what I'm saying? Because every time I press, I'm gonna come to here, shift, and then come back. So here I'm gonna shift here, I'm gonna shift here, I'm gonna shift here. So I'm gonna shift in multiple places here. Okay. So but because of debalancing, what's gonna happen? The program should be frozen here because of this part. I'm gonna once you press, I'm gonna freeze the program here until I reach to this moment, until the press is done. You got what I'm saying? This is what I did in the debouncing. So the program is gonna wait here. Once you press, the program is gonna wait here until you finish, until you release, and then after that I'm gonna go and shift 1 time. Okay. Anyway, I'm gonna choose the same program in C language before I choose the video. Okay. This is the video here. Sorry, this is C language. So here, guys. In C language, for sure, as we said, this part is just initialization, okay? And then here port B equal 1. So here, because I'm gonna turn in the very beginning, I'm gonna turn the LED here, okay? This is configuration only 1 time. Program is here, or the main part of the program is gonna be here. We have infinite loop, okay? Every time. So now, as I said last time, guys, if you remember, so we have a function, okay? You have. I want to do this program is similar to this one. I need to check. I need to check BTH. To check, I told you last time there are 2 ways to check. The first way you can use this function. This function is going to return true or false, right? If the switch is down, here the switch means push button. Okay, let me go back. I think I have a very I don't want to confuse you. But yeah, here, look here, guys. This push button, we call it, that's what the people did the board call it, switch 2. But it's actually push button, okay? This one is switch 3, 4, and 5. What I'm saying is, we have functions, that's what I explained last time, guys. We have functions, what is called switch 2 down, right? So if you press and switch 2 is down means you press, okay? This function is gonna return true, okay? Otherwise, it's gonna return false. We have another function for up. So every switch here has 2 functions. One for up, one for down, right? So here Down is going to return true if the switch is down. Up is going to return true if the switch is up. Otherwise, it's going to return false. So this is one way to check. Okay. Again, whatever you like is okay. The other way is similar to what we did last time. You can use AND operation. Okay. So if you wanna, guys, if you wanna know if you press the button or not, you have two ways. One way to use AND, just similar what we did before many times. You have a byte. Okay, you just want to check one bit using AND, logic AND. This is one way to do it. Or if you like functions, you can use these functions. Okay, here I decided to use functions. So what I'm doing here is the following. Okay, so if you don't press, this one should return true or false. If you don't press, it's gonna be false if you don't press, and then I'm not gonna execute the body. If I'm not gonna execute the body, I'm not gonna do anything because I'm not because you don't press the button, it's false. So I'm not gonna execute the body of F. Then I'm gonna come back here to check again, right? This is exactly the same thing as we did here, okay? As we did here in this part, guys. So if you don't press, I'm not gonna do anything, right? So now, what if you press? If you press the button, what's gonna happen is I'm gonna execute the body of F. I'm gonna come to here. See what I did here, guys? Nothing new, similar to what I did in the assembly, but I'm gonna use the C language. Number one, I have to shift. So shift port B should equal port B shifted one time to the right. So you're gonna shift, number one. Number two, if port B equals 0, so port B equal 1, right? Why? Because if you shift all the way, if you shift the 1, you start from here, you shift all the way, and now port is 0, 0, 0, 0. So now I have to turn this one again. Okay, so after if this LED is on, okay, and if this LED is on and you wanna, if you shift, so this is the one has to be on, and this is off. So I have to bring it back to here. Okay, so I do it here. Okay, and then this is the debouncing code. This code is for debouncing, right? So I'm gonna wait. Someone can ask me, is that okay? Should I put the debouncing here? I put it here. My answer is it doesn't matter, because the program, I'm gonna take action. So this debouncing, okay? Someone can ask me, should I put here? It doesn't matter, right? Because this is what I already took one action, and then I'm gonna freeze. I'm gonna freeze the program here until you release. So if you freeze first and take action, or take action first and you freeze, it doesn't matter, okay? So here I'm gonna wait 20 or 25 milliseconds. I'm gonna wait until you release. So here I'm gonna make while it is down. As long as you press, as long as you hold, I'm gonna keep looping here. I'm gonna wait until you release, and then I'm gonna wait another 20 milliseconds. Okay, guys? Any question, guys? Again, I'm gonna show now this program in the video, guys. Again, this is how it should work. When I press the button, the LED should be shifted only one time, okay? And then I'm gonna take the debouncing code, I'm gonna delete the debouncing code. You will see when I press only one time, the LED is gonna be shifted 4, 5, 6 times, right? Because of these ribbons, or because of these ribbons here. So here is gonna be shifted one time, and shifted one time. For sure, that's not what I wanna do, right? Any questions before I show this video? Yeah, let me show you the video here. Oops. Let me show videos. Yeah. Yes, it's here. Okay, let me. Okay, videos. Yeah, things slides. Okay, chapter 3 and videos. Okay. So where is shifting LED? Yeah. So let me show you now the video. Okay. Let's see this program here. Here each time I press the push button number 3. Look what happened. Look how it is very smooth. Look how I can deal with the bouncing group. I can de-bounce the switch. Look here, very, very smooth. Just quickly, I want to show you if I cancel.
Sorry, guys.
This part that has.
Sorry, I'm going to repeat this part again. So you can see here, guys.
I press the
So let me
look how.
So you can see here, guys, every time I press a button, one time is the LED is going to be shifted one time. You will see it now, right? Now, so every time I press one time, it's going to be shifted one time, right? So you see here. Okay. Once I come to the end, I go to the beginning again, right? So what I'm going to do now in the video, guys, I'm gonna delete the de-bouncing code. Okay. This is the de-bouncing code. I'm gonna comment. As you see here, guys, I'm gonna comment this part. So it's almost, I'm gonna cancel the de-bouncing. What you are gonna see right now, guys, when I press one time, the LED is gonna be shifted 3-4 times. That's what you are gonna see. Okay. Look here. When I press one time, look. Only I press one time. Look. It's gonna be shifted 4-5 times. Look. Okay. Because that's for sure, that's not what I want to do. What I want to do every time I press one time, only one action has to be taken at a time. Okay. Any question, guys? We still have 4 minutes. Any questions? Okay, let me summarize what I did so far, guys. I explained you should know how to use the switches, how you use push buttons. That's what I explained. Also, how can you use LED, how can you generate square waves easily, and that's what we're gonna do in the coming lab. Well, just very simple lab. We're gonna generate square wave. Also, I explained the buzzer. How can you use the buzzer? What I'm gonna explain now, because that's what we need in next week lab, and very small thing, and it's very interesting. We have here on the, if you look at the board here, we have something called RGB LED. Yeah, can you see it here, guys? Yeah. This part here, that's what we call RGB LED. Okay, so tell me how, this is LED, right? Yes, it is LED. Okay, so why, how's it, I already teach how can you program LED. How this one is different? Yes, this one is different because it's RGB. What you mean by RGB? As you see here, guys, it's RGB. RGB, what we did before, guys, we had LED. This LED you can turn on or you can turn off. Is that okay? That's what we did before. Every LED has only one color, but this LED is different. This LED has 3 colors. So this LED here, you can turn it red, or you can turn it green, or you can turn it blue. That's why it's called RGB. Okay, guys? So it's only one LED. This LED, okay, this is the main difference between this LED and what I explained before, okay? What I explained before, the LED has only one color. You can turn on and you can turn off. That's what I explained before. This is another type of LEDs. This LED, you can turn red, green, blue, one of the 3 colors. Okay, so number one, so 2 things I'm gonna explain now. How can you program it, how it looks like. Number 2, I'm gonna explain why you need it. If you look at, this is how it looks like, guys. Okay, so it is like we have 3 LEDs inside this package here. Inside this package, it is like we have 3 LEDs. One is red, one is blue, one is green, something like that. Okay, this red is connected to PP4. Okay, the blue is connected to PP5. The green is connected to PP6. Okay, that means if you want to turn this LED, if you want to turn it red, so on PP4 I have to put 1, very easy, and then I have to put 0 here.
So if PP4 is 1, you actually are going to turn the red on, okay? And then 0 means you are going to, because you see all the cathodes are connected together and they are connected to ground. Is that okay? So it is like you have 3 LEDs. All of them are connected together to ground. So the one that has a 1, you turn it on. The one that has 0, you turn it off. Okay? So very easy. So if you want to turn the red on, so PP4, okay? We still have just 1 minute. PP4, put 1 on PP4 and then put 0 on the other ones. If you want to turn it blue, put 1 here and 0, 0. If you want to turn it green, put 1 here and 0, 0. Is that okay? So this is different from the LED I explained before. The LED I explained before, it has only 1 pin, right? This 1 pin, if you put 5 volt on, 0 volt off. That's what I explained before. This LED is different. This LED has 3 pins. They are connected to PP4, PP5, PP6. Okay? So if you put here 5 volt, the red is on or blue is on or green is on. Okay? This is how it is connected. This is how can you program it. So it's connected to 3 pins on port P. Okay? So this is how you program it. Okay? Only 1 port, 1. Is that okay? Why I need to reflect or why I need to turn different colors, that's what I'm going to explain on Wednesday. Okay, it's 2:50 now. Okay, I'm available, guys, if anybody has a question. So we're going to have a lecture on Wednesday and then a lab. Okay, so see you. Bye. I'm gonna, anybody has yeah, I can see. Sorry, I didn't see the chat. How the assignment said it is due today. What time is due by? Okay, if I'm not sure, if you wanna assignment 5, if you need more time, I can make it Wednesday. Make it Wednesday if you want during the lab time. Is that okay? I'm not sure what time is due by today until the midnight today. Okay, it's okay to me. But if you need more time, I'm okay. We can make it Wednesday. Okay. Assignment 5 is very hard. Okay, so very hard, that doesn't mean it's bad, right? So you need to learn, right? And we should be ambitious in our learning, right? So if you have any question, unfortunately, I have 3 office hours, okay, last week, okay? Anyway, what I'm saying, guys, last week we had 3 office hours. No one showed up. No one showed off in these 3 hours. Okay. If you have any question, this is our job, guys. I get paid to help you. The T is the same thing. So if you wanna, if you have any question, yeah, just do your best. And you have any question in the assignment, in anything, we have 3 office hours. You can come and ask me or ask the TS. Is that okay? Okay, I'm okay. So here you have until Wednesday, but so we need you have to submit it by Wednesday, because I'm gonna post as a new assignment by Wednesday. Okay, maybe today or tomorrow. I'm gonna post a new assignment, so we need to finish assignment 5. Okay, guys, and again, guys, if you have any difficult question, I know. Just ask us. We have office hours. Come and ask us, and we are going to explain. Even if it is assignment and you need some help, we are going to help you. Okay. Anything else, guys? Okay. So the assignment 5 is due on Wednesday. I'm okay with that. Okay. I'm going to post assignment 6 maybe tomorrow or so. Okay. It's going to be on chapter 3. Any other question? Okay. So if you need any help, we have 3 office hours, virtual office hours. So you can just join and you can ask me or the TS. Okay. Okay, any guys. Okay, so see you guys. Bye.
Thanks.